Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 39, NEET Physics paper 2016. Students, let us solve question number 39. It says, the charge flowing through a resistor R varies with time t as Q equals to AT minus BT square. So, this is a resistor. Suppose that this is a resistor and through it the charge is flowing and is given by this expression AT minus BT square. The resistance is R. As you can see that the charge is not constant, it is a function of time. So with time the charge is varying, where A, B are positive constants. So this A and B are positive constants, this cannot be taken negative. So you can imagine that time t equals to 0, the charge is 0. At time t equals to 1 second, there is A minus B. So we don't know whether A is greater than B or B is greater than A, but this is how it is, like this. The charge is flowing in this rate. The total heat produced in the resistor R is, so how much heat is produced from this resistor as the current flows? Because the charge is flowing means current is flowing. When the current flows through this, suppose I is the current, and then heat that is produced from this conductor is equal to I square RT. This is the formula for heat produced. So now, to find the heat produced in the conductor, we have to use this formula I square RT. T is anytime T, and I have to find R is there, so answer will be in the form of R only. T is there, but I have to find this I, then I have to square it. To find I, what is given in the charge, and from this charge I have to find I. How I and Q charge are related? We know that the current basic definition is the rate of flow of charge, dq over dt, how fast or slow the charge is flowing in a given time. So this is the rate of flow of charge that determines the current. If the charge is more in less time, then current is high, and if the charge is less, then current is low. Now, so from here, that means if I differentiate this equation, then I'll get I. So differentiating this equation, differentiate the above equation with respect to time, we'll get dq over dt is derivative of this two terms with respect to time. This will become A, dt over dt is 1 minus B, derivative of this is 2t dt over dt, that is 2t. So this is what is the current is. So the current I'm getting here is A minus 2bt. The current I'm getting is A minus 2bt. Resistance R is used. Heat produced in a time t is I square RT. I is square of this one, A minus 2bt the whole square, R is R, and this t will be there. But but the thing is that because we have to find the total heat produced, so total heat produced, so I have to integrate this because this is variable, so I have to integrate this taking this as a variable time dt. So the dh I'm getting here. So this is the general formula, and I can use the formula dH integration. The total heat produced is I square R dt. Now this is the in small time dt from this conductor. How much heat is generated? dH. Then in the whole time from 0 to t, how much heat will be generated? You have to take the integration. So when you take the integration, you will get the total heat produced, and integrating this from time t equals to 0 to given time t. So from here this will be h, and this equation will be I square r dt. I square r is this one, that is a minus 2bt the whole square. I square r is there and dt is there. We have to integrate it from 0 to t. So this is the total heat produced. Now h equals to integration of 0 to t. If I take integration from 0 to t, I'm just rewriting that equation, 2bt s square r dt. Now from here we will separate the terms, or right, or I can take this as one variable, and suppose I consider this as y, and then I replace this is dy, then I can solve, or directly I can open the bracket and solve. So let us better open the bracket and solve. This is a square plus b square, that is 4 b square t square, minus 2ab, that is 2ab, that is 4 abt, into r is there, so there will be always one r here, r here, r here, and dt. Okay, now this dt is taken inside to each term, and then we'll take the integration. A square r dt plus b 4b square r t square dt minus 4abr from here, and t dt. This, the integration is from 0 to t. Now a square r is common and out because this constant is taken out. Dt integration over 0 to t is only t, plus 4b square r, 4b square r is taken out, t square dt will be left inside, and integration of this is tq by 3, so it will be tq over 3, 0 to t, so it will be only tq by 3, minus 4abr is taken out, t dt integration, and that will be from 0 to t, so it is only t square divided by 2. This is tq by 3, this is t square by 2, and this is only t. Okay. Now so the heat produced in time is not given, so obviously the heat produced will be in the function of time. So this is the heat produced, but time is not given. So as we can see that the option is not having any t. The option is having only A or B in the form of A or B, and we are getting this one. This is also correct, but then you have to convert this in terms of A, B and R. You have to eliminate T. How to eliminate T? You can see that if you see this one, I equals to A minus 2 BT, then from here I can find T in the form of A and B, because when if I put I equals to 0 here, this is 0, then that implies A minus 2 BT is 0. This value is 0, then A minus 2 BT is 0. So from here that implies A equals to 2 BT. This implies t equals to a by 2b. T equals to a by 2b. So if I put this t equals to a by 2b, then my t is eliminated and it is in the form of a and b. So t equals to a by b, so I have to put this t equals to a by 2b that I got in this expression. If I substitute that, I will get a square r, t is a by 2b, plus 4b square r, tq by 3. So this t is divided, this tq is there. Tq is this one, q, that is a cube over, this is 8b cube, minus 4abr divided by 2 is there, t square, that is square of this, that is a square over 4b square. Then you have to solve this to get the answer. I am just explaining everything because those who don't understand will understand. Otherwise, you can just directly put what is the integration of this. Okay, we can directly put the integration, use the integration. That also I'll tell you how to do directly, but then first let us solve. This H will become, the total heat produced is, from here I will write AQR over 2B, and the second term is 4 to the 8, so it is 3 to the 6, so 6 here, B square BQ will cancel, so B square BQ will cancel, only B is left, 4 to the 8, that is 3 to the 6, AQR over 6B plus AQR over 6B minus this 4 will cancel, this B and this 1 will cancel, and this is left with AQR is there, AQR divided by 2B, AQR minus AQR divided by 2B. Okay, AQR divided by 2B. Now this AQR divided by 2B and this is AQR divided by 2B, plus and minus will cancel, and what is left is AQR divided by 6B. So this is the total heat produced. Total heat produced. If I see the option, then AQR over 6B, AQR over 6B, option number 2 is the correct answer to this question. Now, as I told you, in exam you have to directly write for competitive exam what is the integration of this dt. We know that if you take suppose that this is your x, then in place of this you write x here, so this will be x square. So x square integration is x cube by 3, so this will be this value 3 by 3. In the very simple way, in one step you will get the answer, and then dt is replaced by dx. So if I take x is equal to this, then dx equals to minus 2b dt. Dx equals to minus 2b dx by dt. If I take differentiation, then dx by dt equals to minus 2b. If dx by dt is minus 2b, then dt is replaced by dx by minus 2b. So this value q by 3 divided by minus 2b. If you divide that by minus 2b, then also you get the answer in very small time. Anyway, this is for those who need all the steps to see the solutions. So next time we'll solve question number 40. Okay, thank you.